In Module 4, Section 5, we will discuss different equations of lines. Let's start with the slope-intercept form. A linear equation in two variables is written in slope-intercept form. Then the slope of the line is m, and the y-intercept is b. And here we see what slope-intercept form looks like. Y equals mx plus b. Essentially, it is a form of the equation where y is by itself on the left-hand side. This is a very useful form for graphing because we have one point, the y-intercept, already visible, and the slope is ready to use. Let's look at a few examples using the slope-intercept form. So let's begin by using the slope-intercept form to graph the equation. And every time I'm going to write the slope-intercept form down so we don't forget what it looks like, because it is possible that our equations may not start in slope-intercept form. So we look at our equation, we have y equals 3/5 x minus 2. Because y is isolated on the left-hand side, our equation is in slope-intercept form. So to graph, let's begin by finding and plotting the y-intercept. The y-intercept in this problem is -2. Remember, every time we have a y-intercept, the x-coordinate is 0. So we want to find the y-intercept, which we've done, and then we plot the y-intercept. So we plot the point 0, -2. The second step is to use the fact that slope equals rise over run to find a second point. So slope equals rise over run, and comparing our equation to y equals mx plus b, the slope is 3/5, the number in front of x, its coefficient. Remember, the rise, that was the vertical value, so that means we'll go 3 up. Run, that was the horizontal value, we'll go 5 to the right. This is the only instance in graphing where we will not start at the origin. We will start at the y-intercept. So starting at 0, -2, we move 3 units up, 1, 2, 3. We will then move 5 units to the right, 1, 2, 3, 4, 5, and place a point. Once we place our point, we connect the 2 points, put arrows at each end, and now we have the line that represents the equation, y equals 3/5 x minus 2. And we did all of this work without making an xy table and filling in missing coordinates. Let's try another example. Let's use slope-intercept form again to graph the equation y equals 2x. So to begin, let's write what slope-intercept form is. Y equals mx plus b. And let's make sure that our equation is exactly in that form. So we have y equals, y is by itself, that's good. Y equals 2x, but we don't have a constant at the end. To alleviate this issue, we're going to rewrite the equation to make it look like this. Y equals 2x plus 0. Remember, if we add 0 or subtract 0, it doesn't change anything. If you give me $0, I don't have any more money. If I take $0 from you, you don't have any less money. So we can always use 0 as a placeholder. Now we have the slope is easily visible. It's 2. 2 takes the place of m. And 0 takes the place of b. So it's our y-intercept. So let's use the same 2 steps we used before. First, we write our y-intercept as an ordered pair. The x value is always 0. The y value comes from the problem. It takes the place of b. In this case, it just happens to be 0 as well. So we plot the point 0, 0, which is the origin. And then starting at our last point, the point we just plotted, which in this case happens to be the origin, we're going to use the slope. And remember the fact that the slope is rise over run. And we need to figure out how to handle a whole number if we need it set up as a fraction. So hopefully by now we know how to write a whole number as a fraction, and that's by writing it over a denominator of 1. So anytime we have a whole number or an integer, It could be positive or negative. We write that over 1 if it's not already in a fractional form. Because we have a positive 2, we'll go up 2. Positive 1, we'll go to the right 1. So we start at the last point, the y-intercept, and we go up 2 units, 1, 2. We go to the right 1 unit, 1. And we place a point. We now have 2 points that we can connect with a line, and we are finished. Let's try another example. Again, we want to use slope-intercept form to graph the equation. So to begin, let's write what slope-intercept form is. It's good practice, and it will help you remember the formula, y equals mx plus b. And hopefully, as we write that, we see that our equation is not in the correct form. Y is not isolated on the left-hand side of the equation. So we have to go through a bit of work to make that happen. We subtract 2x from each side. The opposite 2x's cancel. We're left with y equals negative 2x minus 3. Now, y is isolated on the left-hand side. We can see that negative 2 takes the place of m, so negative 2 is our slope. Negative 3 takes the place of b. So negative 3 is our y-intercept. Now that we've identified the useful pieces of information, we use the same 2 steps we have in the previous 2 examples to graph this equation. So we start with the y-intercept. We write it as an ordered pair. Remember, the y-intercept always has an x value of 0, and the y value will be the number that we've boxed in green. So now that we found the y-intercept is 0, negative 3, we plot that point. Let's remember that the slope can be defined as rise over run. Here, our slope is negative 2, so we have to change it to make it look like a fraction. So we write it over 1, so we have negative 2 over 1. And because 2 is negative, we will actually go down. So we'll have to go down 2 units. And then we will go to the right 1 unit. So starting at our previous point, which is completely different from other graphing techniques, starting at the y-intercept, we go down 2 units, 1, 2. We go to the right 1 unit, plot the point, connect our 2 points, and draw arrows at each end. Once we do so, we are finished and we have graphed the line that represents this equation. Here is one last example of graphing using slope-intercept form. We have the equation x equals 7/3 y. Before we begin, let's write our formula, y equals mx plus b. And we see that y is not isolated. Y is being multiplied by 7/3. In order to get our equation in the correct form, we need to move the 7/3 to the other side. So hopefully you remember from the last module, if we were multiplying a variable by a fraction, we can multiply both sides of the equation by its reciprocal to cancel that fraction. So we multiply both sides by 3 over 7. On the right-hand side, the 3 over 7 and 7 over 3 cancel, and we're left with y. On the left-hand side, 3 over 7 times x is just 3 over 7x. Now, because we have the symmetric property with the equal sign, we can rewrite this where the right side is on the left side and the left side is on the right side of the equal sign. So if y equals 3/7 x. But we're still not exactly in the form we want. We don't have a number trailing x to let us know what the y-intercept is. So remember, just like we did a few examples ago, we put our placeholder 0 in for b. So now we have an equation that looks exactly like the form we want it to look like, the slope-intercept form. 3 over 7 takes the place of m, so 3 over 7 is our slope. 0 takes the place of b, so 0 is our y-intercept. So we use the same two steps we have on every example so far in order to plot this equation. So we write the y-intercept as an ordered pair. The x value is always 0. The y value comes from the equation. It's the b value. So we plot 0, 0, which is the origin. We then use the information and the definition that the slope is the rise over run. We write our slope, which is 3 over 7. So the numerator is rise. We'll go up 3 and to the right 7. Starting at our y-intercept, we go up 3 units. We then go to the right 7 units. We place our second point. Once we have 2 points, we connect those 2 points with a line, put arrows at each end, and now we have the line that represents the equation. We can also use information to find the slope-intercept form if that equation is not given. So let's find an equation of the line with the y-intercept 0, -2, and slope of 1/3. Just like any time where we see slope-intercept form mentioned, let's write the equation. Y equals mx plus b. Now, when we are asked to find an equation, we are not trying to fill in the values y or x. The values y, x should remain variables for our answer. However, m should be a number, b should be a number. So we need to figure out what those numbers are. As we go back through the information, we're told the y-intercept is 0, -2. Remember, the x value is always 0. The y value is exactly b. So here, -2 is b. As we keep reading, we see the slope is 1/3. And remember, the slope is represented by the letter m. So we're going to put the slope in place of m. We're going to put the y-intercept in place of b. And that will be our equation in slope-intercept form. Let's see what happens. We have y equals, instead of m, we write 1/3. So y equals 1/3 x plus b is -2. We don't really want to write two signs next to one another. Remember, if we add a negative, that's the same thing as subtraction. So we have y equals 1/3 x minus 2. That's as far as we want to go. Now let's talk about another form of lines. We also have a form called point-slope form. Point-slope form is really a variation of the slope formula, and it will be useful almost every time, especially if we have a point and a slope that are given. x1, y1 represents the x-coordinate and y-coordinate that we will need, and m represents the slope. So let's try to find an equation of the line with a given slope that passes through the given point. We'll write the equation in slope-intercept form. Now, regardless of the form our final equation will be in, and in this case it's slope-intercept form, we're always going to start with the point-slope form. The point-slope form is our working equation. Slope-intercept, or standard form, once we introduce it, will be the nice, clean, pretty equation that we show off at the end. So to start, our first step will be writing the point-slope formula. Y minus y1 equals m times x minus x1. Once we write the formula, let's label our point x1, y1. Remember, just like the previous equation where we did not want to plug in for x or y, the same is true here. X will remain a variable, y will remain a variable. We will plug in a number for m, for x1, and for y1. So let's do that. When we plug in, we have y minus 2 equals, m is 8, so 8 times x minus 2. Once we do so, we need to simplify so that we can take our working equation and rewrite it in slope-intercept form. We start by distributing 8. That gives y minus 2 equals 8x minus 16. We then add 2 to both sides of the equation. 2's on the left side cancel. We have y equals 8x minus 14. Remember, we went through both of those steps to get y by itself, because slope-intercept form is y equals mx plus b. So we needed to isolate y. We have successfully done that, so the equation is y equals 8x minus 14. In this equation, we also want to find an equation of a line. We are given a slope, and we're given through the point, or we are given a point through which the equation passes. We want to write the equation in the form ax plus by equals c. This is called standard form. Standard form will be very useful in certain sections once you get to Module 8. But again, it doesn't matter what form we want the answer in. We always start with the point-slope form. So our first step is to write y minus y1 equals m times x minus x1. Once we write our formula, we label our point x1, y1. We will then plug in and solve. So we plug in our information. We have y minus 0 equals negative 1/5 x minus negative 4. On the left side, remember, if I'm adding or subtracting 0, that's completely useless. So we just cross out the 0. That gives us y equals. On the other side of the equation, if I am subtracting a negative, in the case of x minus negative 4, that's the same thing as x plus 4. Now at this point, because we want standard form, and what standard form means is we want x and y on the left-hand side, numbers on the right-hand side. It's going to be easiest to get rid of our fraction. To do so, hopefully remember we multiply both sides by the least common denominator, or in this case where we only have one fraction, we will just multiply by the only denominator we have. So we multiply both sides of the equation by 5. Now in doing so, the 5 on top and bottom cancel out on the right-hand side. So we are left with 5 times y, or 5y, equals negative 1 times the sum of x plus 4. Now we will distribute negative 1. Gives us 5y equals negative x minus 4. At this point, we want x and y on the left-hand side, so we change the sign of x so we can move it across the equation. The opposite x's cancel on the right side. We're left with x plus 5y equals negative 4. And this is the equation solved in standard form. Here we'll try another example of finding an equation in standard form, but we have a little bit different set of information. Instead of being given a slope and a point, we are given 2 points. So for this particular example, we will have to find the slope before we can go any further. So that will be our step 1, find slope. Remember, if we are finding the slope, the first thing we do is label our points and write the slope formula. So we have x1, y1, x2, y2. The slope formula is m equals y2 minus y1 over x2 minus x1. We plug in the labeled information, negative 7 minus 8 over negative 6 minus negative 5. That becomes negative 15 over negative 6 plus 5, or negative 15 over negative 1, and finally a positive 15. Once we have our positive 15, we now have a slope, we have a point, we're going to use the point-slope form. So we write that equation, y minus y1 equals m x minus x1. Make sure you're writing this equation down every single time. That way you will remember it faster when you go to the test and that equation is not given to you. Hopefully you will be able to recall it because you've written it so many times. Let's plug in our information. We know x1, we know y1, and we know m at this point. So y minus 8 equals 15 times x minus negative 5. Remember, when we are subtracting a negative, that's the same thing as adding the positive. So we change that x minus negative 5 to x plus 5. At this point, we want to distribute the 15. And that will give us y minus 8 equals 15x plus 75. We continue to get all of our numbers on the right-hand side, which will be true no matter what form we are asked for, whether it be standard form or slope-intercept form. So the opposite 8's cancel. We have y equals 15x plus 83. Now, if we were asked to write the equation in slope-intercept form, we would be finished. But because we want it in the form ax plus by equals c, or standard form, we need to move our x value to the left-hand side. So we change the sign. The opposite x values cancel on the right-hand side. And we're left with negative 15x plus y, because that was a positive y value, equals 83. Let's try another example. Again, we are given 2 points, and we want to find an equation that passes through those 2 points. And in this example, we will write that in slope-intercept form, y equals mx plus b at the end. Right now, it doesn't matter what equation we want at the end. First, we need the information necessary to get started. And so we need the slope. Again, the first step is to find the slope. We will start by labeling our points, x1, y1, x2, y2. We write our slope formula, m equals y2 minus y1 over x2 minus x1. We plug in the labeled information, and we have 1/3 minus 0 over negative 1/4 minus 0. Just like I've said many times now, if we add or subtract 0, that's more or less worthless. So we cross out those zeros, and we have 1/3 divided by negative 1/4. Remember, if we are dividing a fraction by a fraction, that is the same thing as multiplying the fraction by the second fraction's reciprocal. So don't let that intimidate you when you see a fraction on top of a fraction. Flip the second fraction and multiply, or give you negative 4/3. Once we have a slope, we want to put our slope and our x1, y1 into the point slope form. So we write the point slope form. Y minus y1 equals m times x minus x1. Plugging in gives us y minus x1 is 0 and y1 is 0. So y minus 0 equals negative 4/3, that's the slope, times x minus 0. Again, on the same problem, we see that we're adding or subtracting 0. So we cross out those zeros. Let's see what we have left. Y equals negative 4/3 times x is negative 4/3 x. Y is by itself. We don't see b, which means b was 0, but we don't want to write in a 0 at this point. This will be the simplified equation. Here we are still trying to find an equation where we're given a different set of information. It says we want to write the equation in slope-intercept form when possible. So we want an equation that goes through the point negative 5, negative 3, but is perpendicular to the y-axis. Let's start by drawing our x and y axis. Remember, the x-axis is horizontal, the y-axis is vertical. The point -5, -3 will be somewhere here in quadrant 3. Okay, let's let this point in red represent -5, -3. Now, if our line is supposed to be perpendicular to the y-axis, then it will have to be a horizontal line. The y-axis is a vertical line, and if you'll remember, in the last section we discussed horizontal and vertical lines are perpendicular. So our line will need to be a horizontal line. Once we decide we're going to have a horizontal line, hopefully you remember that horizontal lines, let's go ahead and write that, horizontal lines have the equation y equals a number. It's very good that we remember all of these rules and facts about horizontal and vertical lines. So we have a horizontal line. Its equation must be y equals a number. Now we must determine what number y equals. And the only other piece of information we can use is the point. In our point, we would typically label this x1, y1. So we can see that -3 is the y value. It is the y coordinate. We put that in place of the number, and our equation would be y equals -3. So in problems where we are dealing with perpendicular to a y-axis, perpendicular to an x-axis, could have easily been parallel instead, or if we are perpendicular to an equation with one variable, parallel to an equation with one variable, it's more about using the information we can know rather than setting up formulas and solving. Now let's try to use these tools we've just learned to solve a few word problems. In 1998, there were 1,503 daily newspapers in the country. By 2003, there were only 1,453 daily newspapers. Use this information to write an equation for the line relating years after 1998 to numbers of daily newspapers. Let's first use the information given to set up 2 points. It tells us we want to relate time after 1998 and number of daily newspapers. Now, in this situation, this scenario, because we're looking for time after 1998, we're going to say that year 1998 equals 0. Okay, that's our starting point. Our starting point is always going to be 0. So as we go through the problem, we see we have the first year. In 1998, there were 1,503 daily newspapers. But remember, in place of 1998, we're going to use a 0. So our first point is 0, 1,503. Our second point will be the year 2003. In 2003, there were 1,453 newspapers. Instead of using the year 2000, if we start at 1998, and that's 0, and we add 1 for each year after 1998, then in 1999 it would be 1, 2000 would be 2, and as we count up to 2003, 2003 would be year 5 after 1998. And the number of newspapers were 1,453. So we had to use information from the problem to find 2 points. Once we have 2 points, we need a slope, and we need to go through the process to find our equation. So let's label these 2 points. x1, y1, x2, y2. Let's put those into the slope formula. Remember, the slope formula is m equals y2 minus y1 over x2 minus x1. Using our labeled information, we have 1,453 minus 1,503 all over 5 minus 0. That will give us negative 50 over 5, which equals negative 10. Once we have the slope, we plug that into the point slope formula. Y minus y1 equals m x minus x1. We plug in the information we just found. That gives us y minus 1503 equals negative 10, parentheses, x minus 0. Anytime we have x minus 0, y minus 0, anything minus 0, let's cancel out the 0. That gives us y minus 1503 equals negative 10x. Now at this point, we will add the 1503 to both sides of the equation because we always want the numbers, the constants, on the right-hand side. That gives y equals negative 10x plus 1503. And because we weren't told the specific form, slope-intercept form or standard form, this will be sufficient. So we now have an equation that relates time after 1998 and the number of daily newspapers. Let's try a couple of examples with another set of information. And in these two examples, we will use the fact that we want to be parallel or perpendicular to a line to find a new equation. So first we want to write an equation in standard form. Let's underline that so we don't forget standard form. That contains the point negative 4, 2. We can go ahead and label that point x1, y1. And is parallel or has the same slope as the line y equals 7x minus 8. Now remember, in every other example, we have needed a slope and a point. We already have a point. We've labeled it. We're going to use the information that we are parallel to this equation, y equals 7x minus 8, to find the slope. The first thing we need is the equation given to be in slope-intercept form. Y equals mx plus b. And we see rather quickly that it is. Y is solved for by itself on the left-hand side. And when that's the case, we can compare the number in front of x to m. So in this case, m equals 7. So the original slope is 7. Because we want our equation to be parallel, we're going to use the same slope. So our slope will be 7. Now that we have a slope and we have a point, let's plug those things into the point slope form. Y minus y1 equals m times x minus x1. That will give us y minus 2 equals 7 times x minus negative 4. The only thing we need to change before we distribute is that minus a negative, so that will become x plus 4. Now we can distribute the 7. It gives us y minus 2 equals 7x plus 28. Let's add 2 to both sides. And when we do that, the 2's on the left side cancel, and we have y equals 7x plus 30. Going back to our phrase underlined in blue, we want our equation in standard form, which means x and y on the left-hand side. So we subtract 7x from both sides of the equation. We're left with negative 7x plus y equals 30. And we're finished. We will go through a very similar process if we are given a point and equation that we want to be perpendicular to. So we go through the directions and we want to write an equation in standard form. That's important to remember. That contains the point negative 1, 3. We'll refer to that as x1, y1. and is perpendicular to the line y equals 2x minus 1. Remember, perpendicular means our slope will be the negative reciprocal. I'm just going to abbreviate these for room. The negative reciprocal. So first we look at the equation that is given. We want to compare it to the slope-intercept form. Y equals mx plus b. Because if our equation is in slope-intercept form, we can find the original slope very quickly. It is in slope-intercept form, so that original slope, m, equals 2. But remember, because we are using the perpendicular slope, we must find its negative reciprocal. So it will become, first let's write 2 as a fraction. So it would be 2 over 1. To find the negative reciprocal, we flip. So it's 1 over 2, and we change the sign. The original slope was 2. The perpendicular slope that we are going to use is negative 1 over 2. Make sure that you make the proper adjustment to the original slope before moving forward and trying to solve the problem. Now that we have a slope and a point, we can work out the equation by using the point-slope form. Y minus y1 equals m times x minus x1. We fill in the appropriate information. That gives us y minus 3 equals negative 1/2 times x minus negative 1. Remember, anytime we are subtracting a negative, we need to rewrite that before we move forward. If you don't, it is very easy to lose one of those negative signs or to have too many negative signs and have a sign wrong in your answer. Now remember before, when our slope was a fraction, we multiplied both sides of the equation by that denominator. In doing so, the 2's canceled on the right side. We would distribute 2 on the left side, and we would distribute the number that's left on the right side, that negative 1. So this becomes 2y minus 6 equals negative x minus 1. We move all of our constants to the right side, so we start by adding 6. The 6's cancel. And this becomes 2y equals negative x plus 5. Because we want the equation in standard form, we move all of our x's to the left side. So we add x to both sides. The opposite x's cancel on the right. We're left with x plus 2y equals 5.